In this lesson, I'm going to talk about what is DevOps. In other words, development and operations, right? What is this all about? So let's take a look at in depth for a little bit about next 5 to 7 slides. I'm going to demonstrate what this actually is and what is the role of a person who calls himself or herself as a DevOps engineer. So here's the basic definition among many or several definitions. This is from Wikipedia, for example. A DevOps is simply a culture, movement, or practice that emphasizes the collaboration and communication of both software developers and other IT professionals, such as the network administrator, for example, while automating the process of software delivery and infrastructure changes, right? So they go hand in hand, the ops side of things and the dev side of things. It also aims at establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. And I'd like to add, you need to also build automation. So basically, the second half is kind of important because as we move towards the microservices architecture, away from the monolithic app architecture, newer applications are being developed on the microservices architecture, and they're being made scalable. So for example, you want to be able to scale your application as the organization grows, rather than create a conventional application where you have people sitting in one room and they're trying to write the code and you have millions and millions of lines of code, which is difficult to manage. The microservices, what that does, it breaks that code into something called containers, and we'll take a look at, of course, in this course in depth, how to create images, how to use Docker, and then use the Google Cloud Platform, use Kubernetes to scale those applications. In essence, the main aim is establishing a culture where you build, test, release software, right? Your software versions more rapidly and in an automated manner. So who is a DevOps engineer? So the DevOps engineer is not a singular role or a type of developer or engineer, and the person doesn't even necessitate any particular technical skill. You're also a developer and you're an engineer at the same time. That's the ideal scenario. And this entire course, in fact, aims at making you both a developer and an engineer at the same time, working on multiple tool sets and platforms, such as Google Cloud Platform using Kubernetes, Docker, and then of course Java programming. So instead, a DevOps engineer is a talented engineer or developer with a certain subset of business, organizational, and interpersonal skills. So this is an added advantage if you are a developer and you're also an engineer, yet you also have additional skill sets such as excellent interpersonal skills, organizational skills, then definitely you have a lot of potential. So the DevOps is basically the development, quality assurance, and operations, right? So the middle part of all of these 3 elements is where the DevOps lies. I found this very useful, that you're part dev and you're part ops. So the development end of things, you're looking at applications where you are a modern developer and you use tools to decrease latency, have complete visibility into the code, databases, caches, queues, and so on. You're also looking at end user analytics, quality code, and code level errors. On the right side, you have the ops, where you're also ensuring application availability, performance, end user complaints, and of course analytics as well, like for example, your CPU time, memory, network usage, and so on. So the ideal scenario is that you're both. You're the dev guy and you're also the ops person. So what are some of the tools, right, or the tool chain for DevOps? So because it's really a cultural shift and collaboration between development, operations, and testing, there's no single DevOps tool at this point, rather a set of tools that we use. So for example, let's say regarding code, you may have areas where you need to develop the code, you have to review the code, and need continuous integration tools. For build, you need version controls, you need code merging, you need status. For testing, you need the results that determine performance. You need to package those applications. Then you have to release those. You need to worry about change management, right? Obtain release approvals from management. As far as configuration is concerned, the infrastructure configuration and management also plays an important role. What goes at the back end? What kind of hardware do you need? What kind of servers are required? Are you going to host at Google Cloud Platform, or are you going to use AWS, and so on? And of course, the continuous monitoring of your applications is also required, including the end user experience. So there's a whole chain of events or tools that are required in the DevOps cycle. So why DevOps? I mentioned earlier briefly, the microservices architectural style is becoming the standard for building continuously deployed systems and applications. Of course, you'll get a career boost, as in one of my previous lessons I talked about the salaries of these entry-level DevOps engineer, and of course they're in 6 figures. The future of monolithic app is fine because you may have certain times or requirements where you still develop a monolithic app, but primarily the shift is, or the trend I should say, is towards microservices architecture, because we need scalability. We need these applications to be scalable as the organization grows. For example, let's say you create a website and you have, let's say, 10,000 users or hits coming to your site, and all of a sudden you have 2 million hits coming to your site. What's going to happen in a traditional environment as compared to an environment where you're hosted at, let's say, the Google Cloud Platform? Using Kubernetes, for instance, it will automatically scale that application. So we'll use tools such as Docker and the concept of containers, and once we move to the Google Cloud Platform, we'll take a look at concept of pods, which contains all these containers, right? And these are pretty common words that you hear when you work around the DevOps culture. And there are other tools such as Jenkins for continuous integration, Puppet for infrastructure as code, and Vagrant for virtualization platform, among many others, are often used and frequently referenced in DevOps discussions. So in this course, of course, we are going to use both the Google Cloud Platform, Kubernetes, Docker, and of course the Java programming language as well. So we'll take a look at both end of things. I'm going to make you a developer, right? Entry-level developer, so you're comfortable writing programs in Java. Then you're going to take these programs and scale into a website, right? Use Kubernetes and Google Cloud to host or create clusters of virtual machines and manage that application. And we'll use in the middle something called Docker, which basically containerizes your applications and breaks the application into smaller pieces of code. So if you have a team of, let's say, 1,000 developers, for example, and they're spread worldwide, this is a perfect solution for them. And of course, we'll take a look at a little later on. But in this lesson, I just wanted to demonstrate what a DevOps engineer is and the role of DevOps from both the development side of things as well as the operations end of things. So I hope this helps. Let's move to the next lesson.